Leetcode problem 1043 partition array for maximum sum. So for this problem, we are giving an integer array. So inside it's going to be positive integers from it's not positive from it is integers from 0 to 10 to the power of 9, and the length of the array is 500, and this k is also less than or equal to 500. So partitions array into subarrays of length at most k. Let's just use the first example. So in the first example, we're going to partition the array in this way. This one 157 going to be the first part of partition because the maximum length is going to be 3. Yeah. Now all those values are going to become 15. And then for this 9, we just make it a single value. So this 9 is also okay because only one value, which is less than or equal to 3. And for the last part, we're going to choose 3 numbers, 2, 5, and 10, and both of them are going to become 10. So the total sum of all those values is going to become 84, and it's going to be the maximum value. How can we solve this problem? So according to the value of k and according to the length of the array, it is just 500. Maybe we can solve it by using brute force. So actually it is not brute force, it is a dynamic programming. So the idea is that basically we're going to use the brute force idea to check one by one. So for example, we're going to take this one as our first group. So what is left behind? So this is left behind. Or maybe we're going to take 1 and 15 as the first group, and what left behind is this areas from 7 to 10. Or maybe we just wanted to take 1, 15, 7 going to be the first group, and what left behind is the sub-problem of the DP. So for 1, 15, 7, so the final result is going to be 45 because it's going to be 3 times 15. And what left behind, maybe we're going to use a single 9. So we're going to plus a 9. Yeah. So what left behind is 2, 5, and 10. Maybe we're going to use 2, 5, and 10. So it's going to be 10 times 3. Yeah, so 30 plus 45 plus 9 is going to be 84. So this is going to be the final result. Now let's start programming. I'm going to use a class because currently I'm going to use dynamic programming. So I'm going to use this array, and I'm going to return a tuple of the array. Yeah, because this is the dynamic programming solution, and basically we're going to solve it by using O(n) squared time. So n is the length of the array, or maybe we're going to use O(n) times k times complexity. So 500 times 500 is going to be okay for this problem. Yeah. Now let's just have a check. So we're going to set the length of the array. So if the length of the array is less than or equal to k, so we're going to return the final result. It's going to be length of the array times the maximum of the array. Because it is less than or equal to k, definitely we're going to use it. Yeah, so this is a little bit like a greedy idea. Now we're going to set a result, and we're going to check it one by one. So for I in range k, yes, so from here it's like a brute force. We're going to check all the different cases, but we're going to use a dynamic programming to check that. Yeah. So, but before that, let's just prepare maximum value as well, because we're going to use it. This is just for saving the time. So for each of the time, we're going to calculate a maximum value. So which is going to be array I, which is going to be the maximum of this maximum value with array I. Yeah. Now we're going to use this maximum value to get the final result. So the final result is going to be the maximum value of the result with this depends on how many values we're going to choose from the beginning, from the left side. Yeah, maybe we're going to choose one value, or maybe we're going to choose k values. Yeah, so it's going to be the this maximum value times how many values. It is I plus 1. So this is how many values. So the maximum value, for example, it may be 15, or maybe we're gonna choose just 3 values. So I equal to 2, and it's gonna be 3 values. And what left behind is just f with the array of I plus 1. So this is just what left behind. If we choose like 3 values, so what left behind is from 9 to 5 and 10. And then we're gonna solve the sub-problem. So this is exactly like dynamic programming. And finally we're gonna return this result. Now let me just run it. So object of type has no length, so we cannot use length for this array. Yeah, because for here this is just an empty tuple. We're gonna use this array. We're gonna turn this array into a tuple, and then we're gonna solve it. Let's just try. As you can see now, it works. Now let me just submit it. As you can see, it works and it's passed for all testing cases. Now let's analyze a little bit about the time complexity. So for this problem, we're gonna use we use a test, and we should know that it is dynamic programming, and this array is just dependent on the length of the array. So inside of the tuple, it depended on how many values. So it is the length of the array. So we're gonna use n as the length of the array. So from here, this is just a for loop. So this is k. And here, because we've already calculated the maximum value, and here is another result with the maximum value, so this is just 01. So the final time complexity is going to be n times k. So that is why it works. I think that's all about it. Thanks for watching. See you next time.